Hello, in this video I will show you a simple benchmark for recurrent neuronal network. The benchmark is a calculator. We are try to use at the first step very simple calculations. Only one figure operation, second figure results. That means, for example, 7 multiply 3 is 21. Or 2 minus 5 is minus 3. Or 2 plus 3 is 5. What we want is to have a sequence. We have a sequence of input and would like a sequence of output. For example, when we look on the 7 multiply 3 to 21, we have 7 multiply 3, 21, and the first thing is to know when is the calculation over. And in this case, we make here a dot for it. And we think about what is the input, what is the output. The input is, in our case, 7 multiply 3 equal. And then we make an input like, give me something I don't know, I am waiting. And this is the same as a dot. And the output is, when we have here an figure input and we don't know, or say, I will still wait, I don't know, then I make a dot for an input, output till equal, and then I say, okay, 20, 2, 1 and dot. And when the input and dot and the output is dot, then in our case is the calculation over. I use this simple calculator to analyze and to get the first step to recurrent neuronal networks. In my experience is that the recurrent neuronal networks it goes to the extreme. That has not learned and it was terrible. And I have, after to look into the books and other sources, that some cool guys has developed the alternative or an extension to RNN. This is the long short-term memory networks. In this video, I don't want to dive into the LSTM networks or recurrent neuronal networks because this is not my target. The first step what I want to show you is I have a benchmark for RNN and this is simple. The next step what I want to show you is to show you a neuronal network that works. This is not a recurrent neuronal network, it is a different network, but it has also a memory layer. And this neuronal network has run to 100% correct. That means to every input I have get the correct output, 100%. How looks like my neuronal network? I have at the first step an input layer. This has the values number of 15. That means for every character, input character, I have one input line. That means for 0 to 9, 10 lines, plus, minus, multiply, equal and dot. Then I have here a shift layer. A shift layer is like after every input, before he stored the input to the next calculation, he shifts the input to another area. And this can be repeated. In my case, I have here 6 steps that I stored. I call this layer, like, because I make here a shift, call it shift layer. All these outputs goes to the full connected layer, and this full connect layer has a dropout of 0.5 and has an output numbers of 120 neurons. The next step what I here make is, and this is a little bit unusual, I make here a pooling of 4 values. And I get out here a layer of 30 values. And these 30 values go to, again, a full connected layer. This has no dropout. And the figures are here, are 12 multiply 4. And I make here a next step of a pooling, again with 4 values. The output is 12 values, each value for 1 character. That means for 0 till 9, and for the minus, and for the dot value. And this is 12 characters. The next step what we can make is to make a larger calculator. That means we have a calculator with number 0 till 99, then plus, minus or multiply, and then again 0 till 99, get an output that could be a minus, that are optional, and a number between 0 till 9999 and a dot again. This benchmark I have currently not a perfect solution, but I can get you an actual outline how looks like my neuronal networks is, and then we can go or look into actual results of this neuronal network. This is interesting, but let us look into how it looks like the neuronal network. We have here an input layer again, then we have a shift layer, then we have here 11 steps. The next layer is a convolution network that has 800 features with a kernel of 4, and we make here a pooling of 8 values that get us a feature amount of 100. The next layer is a full connect layer with 400 features and a pool of 2. Again, we have here a next full connect layer with 96 features or neurons and a pool of 8. And the result is 12 values. Unfortunately, it's not 100%. I have a correction rate of 54.3%. Here can you see that you can easily increase the benchmark, and you can make it much harder to learn your network, and it's easy to create such a kind of benchmarks. Let us shortly look into the current results of this network, because that is also interesting. Here on the left side you see an example of the calculation You have in the first column the input values. The second column is the output of the network, and the third column is the target. On the right side, you see currently what is the result of each or every 1,000 calculations. So you can see that he learn long time for this results. When we look here as an example and show us the first line, then we see, hey, it's okay, it's fine. We have 20 minus 47, we get minus 27, the result is minus 27 and fine. You can also see every second is correct, and let us look into the not correct values. Let us look into this here, for example. This is 29 multiplied 76. The result is 2444 in the output, but the target is 2204. That means the first figure is correct, the last figure is correct. The amount is roundabout correct, but not totally correct. But you can see, yes, the number of figures are quite good. Here you see everything, every line, it's correct, but not matched totally. For me, it seems to be that the network is guess the results. For low values or small values, he is quite good, but for large values, he only guess and try to, like a boy or girl that are not calculate, they are make a guess for the results. So that's all. And if you like the video, then I hope you can give me a thumb up for this video. Bye bye.